And now we're gonna take on our next presentation. We're gonna say welcome to Martin. Hello, Martin.
Hey, hi, Magnus.
Hey, hello, and
Hi,
welcome to Prog Sweden.
hi. Thank you, and thank you everybody for having me. Thank you, Magnus, for inviting me.
You're welcome.
I do ever so speak about Wasp and what we are doing, but it's more often on the web development side. So I'm kind of excited. I'm kind of pretty excited to talk a bit more on functional side of the things, Haskell and so on. And also thanks Peter for the presentation. It was quite unique. I actually didn't know much about how maintenance was done even though I'm using it, right, Haskell, though I didn't know much about how it was done from the other side. So this was pretty cool. Awesome. Should I just start, right?
Yes, start. Hit it away.
All right. Okay. So the title is maybe a bit vague. Redefining the future of web development with Haskell. You will quickly see what it's about. One fun fact, same as Peter's talk. This one also does talk a bit about developing and maintaining a language. It will be a very different kind of language, though. You will see what kind of language there is. And even though Peter hoped I would compensate with more code, maybe live coding, that probably won't be happening. I will be having some code, though, so maybe that helps a bit. It's just too dangerous to live code, always a risk. So a bit about me. I finished Masters of Computer Science in Zagreb in Croatia. And I was mostly, dealing with kind of my passion was first maths, then, doing competitions. Then I kind of discovered programming, so started competing there more, on the algorithmic side. And did internships in kind of exciting places like in Singapore. That was more like academic, bioinformatics, machine learning, doing stuff in C++, R, data science. I also did some internships in Google and Palantir, using I think it was also Google was also data science, C++, Python. Palantir was though completely different, web development, and that's obviously relevant for this presentation. And then kind of life took me more into the startups direction. So, I was kind of helping startups in Techstars, worked at another startup, LiveBit, and quite a few other kind of adventures in between. And now actually working on Wasp, which is what this talk will be about. So professionally, I kind of mostly work with Java, C and C++, Python, a bit less, but still. And now lately, mostly, web dev, JS, Java, C, TypeScript, and Haskell. And quite a bit of other stuff, but on a smaller scale. So these days, what I'm mostly excited to talk about, and what's mostly in my head is Wasp. Basically, that's my company, which I'm building with my brother and a couple of other amazing teammates. So it's about web dev and JS in JavaScript and TypeScript, mostly. So that's mostly what I'm kind of excited about. Startups, creating a product, functional programming, especially Haskell, because that's what we are in big part using for Wasp. I do care a lot about clean code. Have always been like, I think, since the college. And I put this one at the bottom. This is more like a wish list. I always imagine I would love to do some game development, even maybe in Haskell, more like for fun than for actually, building something. And every summer I spend a couple of days working on that, and then keep it till the next summer. But if you want to talk about that, I will probably be excited also. And now to get more, to start focus more on Haskell. So how did I get? It was fun for me actually remembering how I got introduced to Haskell. And I realized it happened 14 years ago. If you ask me quickly, I would say it's more like 6 years ago, but time flies by quickly. So it's actually 14 years ago, somewhere at the start of the university. I was actually lucky enough that we had one of, not many universities have it actually. So we had a course on Haskell, which was organized by kind of like an additional activity by one of the professors who was just very passionate about Haskell. And he was also very good at kind of getting that passion, it was very addictive, his passion. I do remember my twin brother. You will notice I'm doing most of the things with my twin brother. So I'll be mentioning him probably a couple of times. I remember this was summer, and he told me, hey, there's this weird language, it kind of, they say it looks like maths, should be fun. They say it's very hard. Let's do it. The next year, there's like only a couple of days to apply. I remember I didn't want to at the beginning because I said you're already doing too many things. I already applied for like a allegedly very hard course in Java. So I thought it would be too much, but yeah, he just strong-armed me, and it was a great decision. So that's how it started. It was one semester of relatively intensive Haskell course. I think he kind of got so far as monads, so no monads, text transformers and stuff like that, but far enough. And since that, I basically started using Haskell whenever I could. Before Haskell, I was mostly using C++ or Java for my university projects, but I remember then I just started using Haskell whenever I could on the university. I think I was like 3 times slower doing it in Haskell, but I had much more fun. And the nice benefit of it was, if it worked, then usually the lab assistant or whoever was checking your code, they would check the code, see Haskell, conclude that's very cool. They don't understand anything, and give you like the full grade if it looks close to working. So that was quite cool. I kind of continued using it and together with my brother on all kind of side projects, and smaller it says here bits and bobs, smaller tasks whenever I could, but nothing kind of big until 4 years ago, when brother and I actually started our own company. I think Magnus said that is I heard him say some points before that it's a nice way to use Haskell is to start your own company. So yeah, we actually did that, started our own company, and have been using Haskell in it for the last 4 years. Actually, the initial course was in big part based on the Learn Your Haskell for Great Good. It's a pretty popular book, and I loved it. So I would say my initial learning was mostly coming from there. But I also read, I remember I was also going through the real world Haskell and Haskell programming from first principles. I probably didn't read through all of them, but significant portions. So yeah, if somebody asks me for a recommendation, I usually point them to Learn Your Haskell for Great Good, even though it's a bit older, but still I think it's very relevant. And now to actually get to Wasp, which I have been mentioning so much. So what is a Wasp? Wasp is an open source project. It's a framework for building full stack web apps. It's a bit unique though, in a sense that it has its own DSL, so domain specific language. You can see it here, at least a small portion of it. We have our own kind of .wasp file. It's not a Turing complete language. It's a quite simple language, declarative, statically checked. It is typed, although you can't define kind of your own types, but it does have types. And it is actually used to define the high level of your web app. So you kind of define all the high level stuff there, and then you go and implement specific details in popular technologies like, there is here React, Node.js, Prisma, that's like ORM in the JavaScript ecosystem. Although we are focusing on the JS ecosystem, JavaScript ecosystem. Actually, we are building Wasp in such a way that in the future it will be supporting like polyglot stuff. So you could also do stuff in Python, maybe use other libraries than React, and so on. So that's like a big vision, and a big part of why we are doing it is this kind of unique DSL. Some other important things to mention: Wasp is still in beta, although it's already being used in production in some places. We have a Discord community. We are backed, so we are a startup. It's kind of there is a lot of R&D, to build something like this from scratch. And we are one of the startups backed by Y Combinator initially, and now by also other European and US investors. We're just finishing raising our latest round, which should like sustain us for the next couple of years, which is an awesome thing. All right. And a quick picture of the team. Right now it's 5 of us. This is my twin brother, Matija here, and this is me. We have the same t-shirts, so you know we are twin brothers. And these are Philip, Micha, and Vini. So it's a quite small team, but really, I would say really powerful. And I will also say part of that is also thanks to using Haskell. We are kind of remote team. although most of us are currently in Croatia, but it's not a prerequisite. And quickly, just to give you an idea of how the whole project is going, lately it has really been growing pretty well. At the beginning, we had kind of like a slower ramp up. To be honest, a lot of R&D and experimenting on our side. Lately, we kind of figured out bigger, like most of the things that are, how they should. Let's say I think we nailed some basic concepts and fundamentals, and now kind of stuff is really picking up. Now it's more like let's say a game of just building things as fast as we can. Now we have a pretty good idea of what we are building and what we are doing. Yeah, now we are already around 7,000 GitHub stars across the two repositories, and there's quite a bit of people using Wasp every day, even though it's in beta. So a bit of a origin story. Why actually create Wasp? You probably saw my when I was talking about my kind of history, I didn't mention web development too much. The funny thing is, like, I was actually more I was always aiming more for a PhD, maybe in the AI or actually bioinformatics. My master's is in bioinformatics, although on the algorithmic side. So mostly like speeding up stuff. My brother was also, I was like speeding up stuff on the CPU. He was speeding it up on the GPU, stuff like that. CUDA. However, funny thing, somehow we always ended up building some web apps on the side, either for some kind of a side project, or, for example, I was working for a fintech startup at some point, doing cool stuff. We were doing cool calculations for option analytics, but then you need also a web app to show that. Then the bioinformatics startup I worked at, again, we needed a web app. So somehow we always ended up building web apps. And I remember I started first with PHP, then it was jQuery with JavaScript, then Backbone, then Angular, then React with Redux, and without Redux, a lot of different technologies. And the funny part is that brother and I, we always it kind of seemed that web development is harder than computer science, because in computer science, I mean, because of the scope of it, of course, and everything. But there's also a lot of, like, every year or so, or every 2 years, there will be a new tech. So you need to learn this new technology, but you're mostly implementing the same stuff. So you're again implementing some pages and auth and calling stuff from the server, from the client, and maybe some real-time stuff and so on. So a lot of repetition. It's not that I didn't enjoy it, but it kind of felt like I'm always solving the same problem. And then at some point we kind of had this idea of kind of separating specification from implementation. And the core of that idea is the solution we thought of was actually creating this kind of a DSL, so domain-specific language, where you can describe your app on a high level. So that's like detached from any kind of lower level technology. It's more about it's just language for that web app people know. It's like I have a page, I have a auth, I have a database, I have this kind of model, stuff like that, right? So you don't want to get into implementation details there. And then you go and implement specific stuff like in React and so on, right? So you have that layer on top that's kind of consistent, and then you can change stuff below kind of faster. By the way, funny thing, Wasp, I know it's like a evil bee, but actually Wasp stands for Web App Specification, right? So that's also kind of coming from this separating specification from the implementation. And kind of things we were always aiming for was that ideally with that kind of setup you would write less boilerplate, be more resistant to these shifts in technology, get best practices out of the box and so on. That was the motivation for Wasp. Now, why we use Haskell for Wasp? Multiple reasons. One was we wanted a high-level performance language we can move fast with. We knew we don't need something that's super fast. We knew we don't need that kind of optimization level that you get with C++ or so on, right? Performance optimization. But Haskell is pretty fast on its own, right? It's just like if you have some very tight stuff, then of course it makes sense to do it in C++ or Rust or something. But we knew we won't be needing that, so that wasn't an issue. We also knew we don't need any kind of specific memory management. So we wanted something high level, garbage collected, and we wanted something with good support for compiler parser implementation because we knew we wanted to build our DSL. Haskell was pretty popular for that, right? It still is. And Haskell does have, you could say like a bad side of Haskell is that sure, ecosystem is not huge, so you might be missing some kind of libraries. Maybe you need something, I don't know, maybe you need a really robust SDK for interfacing with Azure or GCP, Google Cloud or something like that. You might not find that easily in Haskell, or it might be a bit outdated, although there is a great one for AWS, Amazonka. But yeah, so it can be an important factor when making a choice, but we kind of knew that, what we're building a CLI tool, a compiler, code generator, so we knew we wanted any kind of special libraries for, I don't know, like cloud computing or maybe data science or stuff like that. So that was also great. And yeah, we knew Haskell very well. I think even though I was also using it for side projects and so on, I was playing with it a lot and knew it. I think at that point, I probably knew it as good as I knew Java. Another strong kind of alternative was TypeScript, because we knew we were building a solution for web development, so a lot of people will be actual users will be coming from the TypeScript direction. So you might be wondering why not choose TypeScript. Well, to be honest, one reason was that at that point now also I think I knew Haskell better than TypeScript and liked it somewhat better. And the second reason was that we kind of from some experience we had and what we heard is that anyway, the core part that we will be doing in Haskell will be mostly dealing with compiler stuff. And we didn't kind of expect, it anyway requires pretty specific knowledge, compilers and so on. So anyway, it won't be so easy for casual contributors to contribute. On the other hand, usually people that know Haskell also know a lot about compilers. So it sounded like a pretty good match. Still hard to say, I think both will be fine, but yeah, we really like Haskell. A bit about how Wasp works. So actually at the core of everything is Wasp compiler. Imagine it as a kind of binary CLI in the CLI. So binary written in Haskell. It takes a .wasp file. That is the file written in the DSL I mentioned, which we compile. And it also takes a bunch of, React files, Node.js files, Prisma files, CSS, HTML, right, whatever. So basically all the other stuff that is referenced, by the way, here in .wasp. So it takes all of these, that all goes into Wasp compiler, and it spits out, it's like the code generator actually spits out the whole full stack web app. So produces a client, server, backend, right? Deployment scripts, whatever. It could be even multiple clients, multiple servers. That's something that we will probably have in the future, like in the web client, mobile client, and so on. So what's kind of quite unique is that it has this kind of compilation step. So you can, it's like opportunity for it to maybe optimize some stuff, inject some stuff in the code, remove something, it gives it a lot of control on what it's actually generating, right? And that is probably the main difference compared to like your typical web framework that you have out there. By the way, fun fact, you could say that any web framework like Ruby on Rails or Next.js or whatever, right, is DSL. However, most of those are like EDSLs in the sense that they're embedded, in the sense that they're quite heavily embedded into the specific language like Ruby, and they don't have, at least not to this degree, this kind of separate compilation step. Maybe to some degrees they do, but not like at this level and not this heavy code generation, which is really the whole idea of Wasp, maybe even more than the DSL itself. It's kind of more about this whole compilation, very, very, very isolated compilation step and controlled code generation. Maybe a bit more interesting. So let's dive into Wasp compiler. So Wasp compiler is written purely in Haskell. It takes in, as you saw on the previous slide, .wasp file and everything else that's in the kind of source directory, as you said, JS, React, Node, whatever. It has two main parts, analyzer and generator, and the main intermediate representation, which is called app spec, kind of like app specification. So it actually describes your your web application at a high level. It's kind of like a in-memory representation of that .wasp file, right, with some additional stuff in it. And it is what decouples the analyzer from the generator. So, so we can in future have multiple frontends, like multiple analyzers, multiple generators, and so on. we are actually right now in the process of implementing an alternative analyzer. I will speak more about that. So alternative frontend, which is enabled by the fact that we have this decoupling. Analyzer is both pretty typical and not. So it's like a typical kind of architecture for a compiler. It has like a parser, which produces a kind of AST type checker, which produces a type checked AST. And then this step, which is a bit more maybe unique, but it evaluates not to like, it doesn't actually execute the language, but it produces this app spec representation. And then that goes into the generator, which generates, like a client, generates a server, it generates a database, and so on and so on. It uses heavily masters templates. There's a very nice library in Haskell for dealing with masters templates. And then it produces something. So it actually doesn't write directly to disk, doesn't generate a project directly to disk. It actually creates something called file drafts, which are like in-memory representations of what you want to write. And then there's like a kind of optimized, kind of a smart function which figures out what actually needs writing, what doesn't, what is already written, and so on. And which at the end generates your web app on the disk in like JavaScript and HTML and CSS and so on. I mean, the one, just to be clear about something, this is not, when you're dealing with Wasp, as a Wasp user, Wasp developer who is using Wasp, this is what you care about, right? This, you can go if you want, you can go check out this code, but you're not supposed to be changing this code. This is just the artifacts of compiler, right? Kind of like C++ is compiled to assembly. So what is in the same sense, Wasp compiles to, whatever are the technologies behind it, like JavaScript and all that, so on. Although there is a benefit that if you really need to, you could in theory go take a look, steal something, maybe take all of it and go with it if you're, although there is no need for that, right? Perfect. One important thing to mention here is that even though kind of implemented all this ourselves, I probably know less about compilers than your typical compiler developer, because Wasp is just also pretty simple language. Language is not Turing complete. You're not doing any kind of like for loop optimizations or fusions or whatever, right? So it's in a sense it's relatively simple. It is also although we do use some smart mechanisms here that make this part kind of both fun and complex, some template Haskell and stuff like that. So there are some pretty cool parts here. All right. Besides Wasp compiler, we also have some other interesting parts done in Haskell. So we have Wasp language server. Since it's our language, we have a VS Code extension. We don't have yet extensions for like Vim and Emacs, although Team is mostly in Emacs and Vim. But we do have Wasp language server, so it's quite easy to implement those extensions. There's like a typical language server. We were lucky kind of that there is an open source version of actually LSP library on Hackage. Which is used for actually implementing the Haskell language server. So for the Haskell language itself, right? So that same LSP is open sourced, of course, and we use it to implement the support for Wasp, and it was great. So kind of great experience there. Also, another fun thing we kind of did in Haskell for Wasp. This is more like a side project we did in I think probably a month. So basically, what we did is we implemented. Let's say GPT wrapper. You give it a title of your web app. You describe your web app in a couple of sentences. Like for example, to the app, it has a main app, lists all the tasks. Each task has description and can be toggled as done or not done. User can add new tasks. Okay, right. So for something pretty simple, it asks you, which GPT combination you want to use, how much do you want. Basically, you're setting the temperature of the LLM. And it generates an app for you in Wasp, right? So it generates a Wasp project for you. This is all done in Haskell. It's not a super complex project, but it's also not trivial. And it was, I have to say, it was a joy implementing it. There was like a small part which basically we're using OpenAI API, so we kind of modeled communication with that. We make sure that that responses we get are correct. We ask again for them. We check the generated code for correctness. If not, we again request a couple of retries with GPT. So kind of trying to remove that non-deterministic reduce that non-deterministic behavior of GPT, and so on. And we actually got, like, it was, I kind of loved it because it really showed, it confirmed again how Haskell, you can prototype really quickly, and we actually got really nice results with this. And you can see, yeah, this is like a typical example of, it kind of figures out, okay, yeah, I'll make a web app for you. It will have these kind of data models and these operations and these pages, and it generates all those. So that was quite fun. All these and some extra stuff, but I won't be mentioning all the small things. We're actually shipping all this as one binary. We found that most convenient and works perfect for now. Helps a lot with the versioning and so on, which is called Wasp. You can actually, so once you install it, you can actually create a new project. You can create it using AI, which uses the AI thing. This one is also used actually by your editor to run the Wasp language server. And you also use it basically for development, right? So it actually runs the generated app for you, like it runs Node in the background, it runs all the React code and so on, database for you. So does telemetry, all a bunch of different stuff, builds it for deployment and so on. So basically, we ship it's one big Cabal project, and it's all shipped as one binary. And to talk about a bit more about the whole Haskell side of things. So we are kind of sticking to the boring Haskell manifesto. I don't know, probably you heard about it. I can't remember, was it Chris Dunn or was it Snowman? But some prominent figures in the Haskell community were talking some time ago about the idea of boring Haskell, in the sense of, let's not go, when we are doing a code base, let's not go crazy with the template Haskell and lenses maybe, and some, complex FX systems and so on, right? Like, it's good to use them if you need them, but if needed, let's keep them localized. And if you don't, let's not use them. Because that really allows, junior developers or maybe intermediate developers and new people joining the team to kind of ramp up, to join quickly, become productive. Code is maybe easier to maintain and so on. So we're also sticking with that. Also, I don't know if I made it clear or not, but the whole team is actually, we are doing part of our coding in Haskell, a lot of our coding also in TypeScript, in JavaScript, in React. So every developer in Wasp is actually dealing with a bunch of different technologies, deployment providers, bunch of stuff, right? So it's kind of, it's not just Haskell that's in our heads. So if we can keep the Haskell code simpler, it does actually help with all the switching, context switching, and working on all this stuff. So we're sticking to that as much as we can. One interesting thing is we started with Stack as a project manager. It was great. I loved how it managed the GHC for us, GHC version, and yeah, helped versioning a lot. We did some time ago, we actually switched to Cabal, which mostly, like, now thanks to GHC app and improvements on Cabal, just proved to be like a simpler option for us, and it works equally well. So now we're on Cabal, and we're also using that for other side projects. So that was one interesting kind of Haskell journey we had. You will see I will talking about a couple of these Haskell journeys. Interesting side maybe on the compiler, we started with just parsec, had some kind of ad hoc parser for our language. Then at some point we had this amazing contributor from the USA who joined us for a couple of internships and probably wrote the most complex Haskell code we had, and in a good sense, like really cool stuff. He actually did the whole Alex and Happy thing for us, implemented the proper grammar, with all the formal stuff. Used Alex and Happy. That was great. At some point, however, we actually switched to Alex and Parsec again. So we're both happy with Parsec. Happy is awesome, but we were lacking a bit of flexibility on the error handling side, and the error reporting, error recovery, which we needed to be pretty granular, and we needed a lot of control on it because of the language server. So language server has some kind of special needs, and we didn't want to implement like two different things. So we ended up just going with a more custom thing, which was again based on Parsec, but also going a level higher than we were going before. So it's kind of like ramped up Parsec thing. And I think that's working really well right now. one fun journey we had was this is maybe pretty unique for Wasp. We're actually dealing a lot with file paths. So we, users bring their own files, right? We are taking those, parsing them, dealing with them, not parsing everything, parsing some stuff. We are then transferring those to the generated project in a lot of them, connecting them with our own stuff that we are generating. So it's a lot of, like this file is here, it's there, I need to import it here. That also means we are often generating like JS import statements in the JS code we are generating. So that also needs to be correct. You want that to work for, for Linux, for Mac, for Windows. So you need to be also careful about the platform you're working on, the platform that the user is coming from. So a lot of details there about the file paths. And at the beginning, we had quite a few, like more than we wanted to, bugs connected to actually the file paths. And if you're in Haskell, always your first thought is, why didn't they capture this in the type system? So I remember I found this amazing library called Pet, written by Chris Dunn. We used that for some time, but then we realized we want even more type safety, so we actually implemented our own thing, which is heavily inspired by Pet, called Strong Pet, and now we are using that, and we love it. I mean, I'm subjective, I wrote it, but I had some people from the team say that they also like it, unless they were just trying to be kind, right? So yeah, I would say awesome experience with that. Surprisingly, usually, Wasp is a pretty big Haskell project at this point. We still don't use lances. Use them just in a couple of small places in LSP, like very localized. We still don't use lances. We probably could, but I think the need just wasn't big enough. I guess we had luck that we didn't have such deeply nested structures or something. So yeah, they'll probably come at some point in the future, but sticking to the boring Haskell manifesto, for now we are kind of avoiding them. We are using we are not using any super fancy FX systems, just like MTL with some transformers. And some of the, I think, notable, like there are many amazing libraries you're using, but I think some of those that were like a nice surprise, like, oh, wow, like this is implemented, was LSP, certainly, that I already mentioned. It was opt-parse applicative, which is like for, doing all the CLI stuff, like parsing arguments and producing the help instructions and so on. That's an amazing piece of software. And yeah, we're using Tasty and HSpec for, and QuickCheck also for testing. And that's, also had a great experience there. Even this stuff like golden tests and end-to-end tests and so on, or snapshot testing. A little bit on the strong pet. So what is that? How does that work? I don't know. Yeah, as I said, I wonder how many projects actually need something like this. I would say all of them. Like now, for me, it's very hard to not use it on any project. But I guess like you probably need some kind of you probably need a bit more of file path kind of challenges to actually think of needing something like this. But in Wasp AI, it's very, very needed. As I said, it's inspired and used, and it's inspired by and actually heavily used. So it's like a kind of wrapper around the Pet library implemented by Chris Dunn and maintained by his teammates. Just to give you a quick idea of how this works. So imagine, without strong Pet or without even the Pet, you would, say, I don't know, I have this kind of variable or function or whatever, get bash profile, which does some IO and returns a file path. In Haskell, if you don't know, file path is just a type alias for string, right? So basically, you're not getting much type safety here. You're just in a kind of string. With strong path, you can be much more elaborate, and you can say, it's a file path, right? It's system. It could be either system, Windows, or POSIX. Those are like I didn't even know, to be honest, what is all the choices you have before I had to deal with this, but is it like does it have separators on this side in Windows or on that side POSIX, or it maybe depends on the actually whatever it is, if it needs to adapt to whatever system it's running on. If it's Mac or Linux, it's POSIX. If it's Windows, then you put system. So this path, yeah, it's following the system kind of standard. It's relative to something that's called home directory. So it's a relative path. It's relative to home directory. And it's actually a path that leads to a file And that file is actually a file called bash profile. By the way, the pet library does also part of this. But if I remember correctly, it doesn't do you can't kind of name, these things, which was important for us because it ensured, I'm not by accident mixing some pets. So you can't use these names like home dir or bash profile, and strong pet also pushes a couple of other things step further. I do also remember while implementing strong pet, I actually realized that pet has some kind of bug in how it differentiates between the standards. So that was also like a nice opportunity. I had a bit of, I managed to meet a bit like some of the maintainers and online GitHub and collaborate a bit with them. So we also merged the fix into pet, which then helped us also to improve the strong pet. And yeah, simple but a bit more complete example for you is here. Yeah, for example, you could have a function that says, give me a home dir pet, similar to this, also IO. But it could be, in this case, it could be like a absolute file pet. You can say to what it's absolute to the root dir, right? And it points to a directory which is called home dir, and you can use like a nameless, is that the correct name? I forgot a bit. This type, which is basically just like a single, has a single value, right? There are a lot of uses to this, and you can check it out like if you want on this Hackage page. And besides that, we're trying to give back when we can to the Haskell community. I feel like we could do a bit, I guess a lot more, but we're also trying as much as we manage next to our other kind of tasks. I would say probably the biggest thing we are doing. So you remember that university course I mentioned at the start about the university course I attended, and that really started this whole journey for me. By the way, a big part of the team also attended that course at some point. So actually, we are now leading that course. A couple of years ago, the professor didn't kind of he was leading the course for quite a big time, but it was I think a lot of work, and he didn't have much time left for it anymore. So we kind of jumped in at the right moment, so it, and took it over. So it continues its life. And now we are leading it for the last couple of years. So that means every semester we have like something between 20 and 30 kind of ambitious university students, computer science students who will teach Haskell. And I love it. It's funny how in my normal work, I don't use some things like folds and list comprehensions and so on as much as you would expect. It's more, I guess, when you're mostly implementing business logic and you're dealing more with types and so on, business data. So yeah, it's fun. It's actually good kind of refresher for me every year, and it's also just very, very, very rewarding work to teach other people. And the whole team, actually, the big part of the team is actively being engaged in this every year. I had the opportunity to actually contribute to creating a new version of Get Started page on Haskell.org. I don't know if you noticed, but I think like a year ago or something like that, me and a couple of other Haskell people from the Haskell community, we got the new page out. To be honest, for me, the most things that drive my ideas about how to contribute to Haskell actually come from the university course, because we have this unique opportunity to talk with all the students, and we then see where the new people, how people learning Haskell actually, all the places where they failed, right? So all the places where kind of Haskell actually fails them, be it docs or be it just the ease of usage and so on. And one big part I noticed I felt was important, and I think I noticed is that this kind of first impression when you get to Haskell.org and you want to start was kind of could use an update. So that was great, and I love the experience of being able to contribute to something kind of that integral in the Haskell community, even though I'm kind of an outsider. I haven't done any big contributions to the Haskell ecosystem before, right? So that was really cool, and I think a big benefit of how Haskell is somewhat smaller community. We also have something called Haskell Handbook on our GitHub. It's not meant like we mostly just write tips and tricks for ourselves there, like in short format, so we don't forget about some stuff. and ideally it will be also useful to some other people. It's developing pretty slowly, but if you like it, I saw it has quite a couple of GitHub stars, so I'm guessing people do find it useful. I use it usually for myself as a reminder for, like, for example, for template Haskell, right? So I go there, quickly check my the kind of cheat sheet for it, and it helps. And also when they can, they try to write some blog post tutorials and so on. I found fun this one. I was trying to solve algorithms for the algorithmic competitions with Haskell, and then publishing, comparing Haskell to C++ and so on. And some other members of the team also are writing blog posts. And yeah, this is the last slide. So a bit on the future and learnings. I mean, when you learn another language, I wouldn't say I'm still not sure I would call myself like a Haskell expert. I think I'm somewhere in the there's so much more to learn. But the more you learn, of course, about all the problems and issues. And so Haskell is not perfect, but I have to say I enjoy it a lot. I think it's awesome. I had the opportunity to work with a lot of other languages, and I'm still working with a lot of them, also JavaScript, TypeScript. And I love Haskell. Like if I have the opportunity to, like if Haskell is a good match for some project, I would always kind of go for Haskell at this moment. And still, I know it, like GADTs, like how you can define new data types in Haskell. It's such a simple feature, but usually when somebody asks me what is my favorite feature in Haskell, it's that it's just it's so simple to define kind of your problem with that I don't know, I feel like everything, like my brain just loves it, right? Everything goes kind of easy. So I think Rust also has it, but Rust is not high level and garbage collected. So then if you don't want to think about all this stuff, then Haskell is perfect, right? One learning we had with Haskell is that actually generalists, like a bit more experienced developers, not too much, like intermediate or a bit more, that have a bit of general knowledge to a couple of languages, they saw multiple things. They learn Haskell really quickly. We had people join the company who have never done anything with Haskell, and they were completely productive in something like 3 months while also doing other stuff, right? Like while already working on Wasp, right? So not like just sitting and learning Haskell, but like learning it bit by bit, and in 3 months you have them at a really, really good level. So I would say we didn't have problem ramping up people to Haskell, to be honest. Maybe the juniors it will be different, or maybe it wouldn't. I'm not sure. We'll maybe experience that in the future. I did learn that people are scared of Haskell a lot. We saw that the students on our kind of that are taking the course, they all come with a lot of wrong assumptions about it. That they think it's not Turing complete, or that you can do only specific stuff with it. That you need to know category theory is super hard. Nobody uses it. It doesn't have any ecosystem, stuff like that, right? You can do web development with it, whatever, right? So that's a lot of misconceptions. People are also scared of it. Funnily enough, so we are doing, as I said, we are building this solution. So the Wasp, the thing we are building, is not for Haskell developers. It's for web developers, mostly using TypeScript and JavaScript. Funnily enough, if they saw that we are building it with Haskell, even that was enough to scare people away. It's like, oh, this is using Haskell. I need to know Haskell. These people are, not or maybe doing something very, very, very unusual, and that's also something that scares people. So yeah, this kind of reputation, I think this very wrong that Haskell has, can sometimes be a bit tricky. And so it's more like I would say something I care about, and I would like to see in the future is just kind of from the Haskell side, is just maybe like promotion and marketing, in the sense that to kind of dispel those wrong assumptions about Haskell. I think it would really help Haskell a lot. And one thing we learned, I think, is that building dev tooling for a language is really hard. So that is it's like building compiler is hard, but then building all the tooling around it, like language server and integrating it with different editors and so on, that's really hard. It doesn't have anything to do with Haskell specifically. It's just like a hard problem. So yeah, that's maybe like a important lesson. So we'll see. We are also managing that in Wasp in different ways. We might have, as I said, we will be introducing probably like alternative way to defining a DSL, even maybe in TypeScript or something like that, compared to our own DSL, because it will be very easy, much easier to maintain, and so on. You can see, if you want to check that out, you can check more like our Wasp Discord or something for more information. And that's it. Yeah, thank you.
Thank you very much, Martin. A very appreciated talk. Thank you very much.
Cool.
People have
Thanks.
shouted out, or I have some questions from the chat for you. Can you
Mhm.
compile towards another JavaScript framework than React or render/compile?
Yes, so that's a very good question. So the whole Wasp is built so you can do it, which is why we have like you can switch, you can implement multiple generators. So you could have generator for React or generator for Vue or Svelte or whatever. We are focusing right now, to be honest, we're a small team, so we want to get one thing working first. So now it's React Node and Prisma. But yeah, everything is built in such a way that you can also add other front-end languages, different backends, and so on. We will most likely be adding Python first at some point as a backend because we had some requests for that, and probably something like Vue on the front end.
Of course.
Yeah.
Seems reasonable if you want to spread the Wasp.
Yes, exactly. Yeah.
Do you keep dynamic part in the user's program is also a question.
Do we keep, can you repeat that? Do we keep dynamic? Sorry, Magnus.
Yeah. Do you? Oh, sorry. Yeah. Do you keep dynamic parts in the user's program? Like once it's compiled, do you keep it? Depends on what you.
Okay. That's yeah. I'm not. I think I'll probably be able to answer it in some way. Although I have to admit I'm not entirely sure what it's addressing. But just to clarify it maybe a bit, we are not really doing some heavy compilation. So you have Wasp file, which is just pretty simple declarative static language, and then you just define your kind of your actual implementation in JavaScript files like React Node and so on. So we kind of use that as it is, right? So we don't take out anything, right? So we just use that as it is, and the Wasp part, there's nothing. The Wasp code, there's nothing dynamic about it. It's very static, and we just kind of use it to orchestrate the rest of all the other JavaScript code that you provide. So I hope that answers the question.
Yeah, exactly. The question was like, it's part of the compilation. Is some part left for the runtime?
Yeah, actually, no. That's pretty interesting. Yeah, so we just do it all in the compilation time. We spit out the whole project, and then we are actually running that. Yeah, there is no typical runtime. There is no typical runtime in a common sense that you would have in a normal language. Yeah.
How is the UX during development? Do you support hot reload and keep of local states?
Yes, the UX is great. No, of course, I'm joking a bit, but yeah, we're doing our best to make it great. I think also, as Peter mentioned, when you're working on something, you know all the bad parts of it. So if you want to hear all the bad parts about UX, you will learn the most just asking me or any of the teammates. But I think UX is also great in many ways. We do have hot reloading and stuff like that. Yeah, normally, of course. So that is all there. If probably some small things are missing, like so for example, we don't have stuff like I think lazy routes, or all this coming very soon. We don't have a static server side. We don't have server side rendering yet, but all that is kind of coming. Wasp is still in beta, so our focus is mostly now on getting these kind of innovative parts working the best we can, and then the some of the, let's say, more expected parts we are adding now and soon. Yeah.
Great. Final question: is there a link to the course you're having? People are asking in the chat.
A link to that's interesting. Actually, so in the presentation I gave, which I haven't shared with anybody. All right, so I can actually share the link later, probably. I would be happy to. I would be happy to share it in Discord. The course is not streamed or anything, and it's heavily following the book that I mentioned, Learn Your Haskell for Greater Good. So a big part of experience you can get there. The big part of experience you can't get is that we actually do we work with students, we do code reviews, we have homeworks. And then like small exams, right? So all that is, and we also have live classes where we help them. We did have discussion last year if we should be live streaming the whole thing. So let's talk about it. If there is enough interest, I think I can also take that to the rest of the guys, and maybe convince them to live stream the whole team, or at least record it so we can put it somewhere. So that would be,
exactly. Yeah. Again, thank you very much, Martin.
Thank you, Magnus.
Yeah, you're welcome. You're welcome. And thank you very much, everyone, for joining tonight. And thank you very much for everyone asking and being very engaged in the chat. It's always nice to see people engaged, and also nice for the people doing presentations that you're engaged in the chat. And it's also nice for us organizing the meetup. Now, we'll end for tonight. And for those of you who want to tonight or today, depends on where you are, please head over to the Discord server and ask questions and join in and ask more questions, more elaborate questions. And also Martin will share the link to the course and etc. So thanks, and maybe I see and hear some of you in Discord. Bye for tonight.